Okay, sorry for the delay. Okay, good afternoon. So, are there people who were not in the previous session on robotics? Okay, so for the other one, there will be a bit of repetition, but it's important that everyone has at least the framework and the introduction. So good afternoon. Thank you for coming so numerous in this session and your interest. So my goal is to give you as much information as possible to help you and guide you in preparing your proposal and to tell you what's in and what's not in, so you don't waste your time in writing a proposal if it's not the topic you had in mind. So my name is Cecilia, and I'm the Deputy Head of the unit Robotics and AI at the Commission, and we are in charge of this call on ICT9 and ICT10 in robotics. So I will give you a bit of a framework. How does this call fit in the overall work program we have for the years 2018, 2020. So we have some kind of grid and some kind of structure on the calls we have. So in terms of applications, our public-private partnership, so Robotics is the private partner representing the whole robotics community, identified 4 priority areas in terms of application, and they are in healthcare, inspection and maintenance of infrastructure, agri-food, and agile production. So that was for the applications. In terms of core technology, and this is the very point of this ICT10, they have identified 4 core technology where we need to make progress eventually to boost the take-up of robotics in applications. And these are AI and cognition, cognitive mechatronics, socially cooperative human-robot interaction, and model-based design and configuration tools. So number 1, application. Number 2, technologies. Number 3, instrument. How are you going to implement those activities? What are the best tools to progress in application, in technology, and in deployment? So we have identified 5 actions. Digital innovation hubs, where the goal of a digital innovation hubs is really to help the local economy to take advantage of digital innovation, and namely in this case, robotics. Research and innovation projects, so the standard research and innovation project we have been funding for many years. Large-scale pilot, these are innovation action, and this is a bit specific type of innovation action. And competition and coordination. So competition, it's the presentation I gave just before as well. We want this time to have competition in the 4 application areas. And finally, we will have a number of coordination action. So here is the structure of our calls. So around those 4 application areas, we have those tools. So digital innovation together with a coordination and support action, helping those 4 large projects on digital innovation hubs. So these were selected in the previous call. So the project will start running as of early January. Then we want also to continue doing research. We know it's very important to continue investing in research in Europe in robotics. So we have this call ICT10, and we also have a more open topic in ICT9 regarding research. We have innovation action because we need to show how the technology can be deployed. So this is the pilot action that we're using to demonstrate that. And the competition is also very important to demonstrate the project, to really have a reality check in terms of what the technology can do. And so that people understand it's both going to inform the public and potential user of the technology. So in terms of visibility, dissemination is really important, and also to demonstrate progress in terms of what the technology can do. So in terms of timing, of the whole work program 1820, so I already mentioned Okay. The call we had last year was about digital innovation hubs and the coordination action to help those digital innovation hubs networks. We had the intention to fund one digital innovation hub networks of 16 million euro in each of the application area. It happened that there was an accident in the submission of the agri-food, and eventually we are going to evaluate it only now. There was then a delay in evaluating it because of that problem. So for the moment, we have selected and funded 4 projects, 1 in healthcare, 1 in inspection and maintenance of infrastructure, 2 in agile production. Now the following step is we are evaluating next week the agri-food one, and depending on the results, either we will have one in agri or we will not have one in agri. So that's the unknown for the moment, but it's all what I can say at the moment. And then we have the coordination and the support action, and there will be a short presentation of their activity right after my talk. And so that was last year's call. This year's call is this one. So we have 2 topics, ICT9, which I just presented before this session, and ICT10, which is focusing on research and innovation in those 4 core technology I mentioned before. So these are the one on the right-hand side. And to give you a bit, these are 2 complementary calls. We also have a line of research and innovation action in ICT9. In terms of technology, it's broader, so it's open to any kind of technology, so it can cover those, but others as well, so all technology. And so if, for instance, if you want to have underwater robots, they might not be in the core technology, but you can submit in ICT9. But you have to be aware that the ICT9 specifically excludes, in terms of application domain you are using to demonstrate the progress of the technology, it excludes the 4 application areas which are listed in the code. So that's very important for you to know which one is focusing on what. So in case your technology is going to be demonstrated in the 4 application area, the only way for you to have a research project is to go to ICT10. In case you're going to other applications, which are not those 4, then you go for ICT9. Pilot, it's, as I said, an innovation action in a large project in ICT9 to demonstrate really how the technology can be used in inspection and maintenance as a priority area this year. And the competition is going to address the 4 application area and show progress via competition and challenges in those 4 application areas. This is for information. Next year, we will continue our investment in both research and application area. And so this year, the focus of the large-scale pilot is on inspection and maintenance. And next year, we will have a large-scale pilot dealing with healthcare in the topic Smart Hospital of the Future. And the one on agri and agile production will then be in the ICT9 for next year. So there will be, again, one open Python research and one specific one targeting those technology area. And as I said, these are the pilots for next year. OK, coming back now on the specificities of ICT10. So the focus is on research and innovation action. So the focus is research. And then what we want eventually to have is to have robots which are smarter and more autonomous. So that's the underlying principle we want to push here. And therefore, we, in order to achieve that, we have identified, the PPP has identified 4 core technology we need to push: AI and cognition, cognitive mechatronics, socially cooperative human-robot interaction, and model-based design and configuration tools. We will see more in detail what it means. Which kind of stakeholder do we expect? So academia and industry for sure, to both develop and use the technology. And if you have an user on board, it's also always useful to help you designing scenarios which really demonstrate progress in these applications you are targeting in your proposal. So even though it's research, it's always good to be driven by some user needs to understand that your technology is actually helping in solving some problems. The budget for each proposal, 5 to 10 million per action, and the total budget is 42 million in total. So the deadline for the call is 28th of March, and you have the link to the call text here. So going more in the detail of what it's what is meant for each of the core technologies. So the goal of Cognition is to bring some advanced, let's say, understanding within robots, so some intelligence in the robot, between quotes, so that they can adapt and interact with people and their environment. So they have to have sufficient understanding, so perception, understanding, and then adaptation to the environment, and so that they can have a sufficient level of autonomy so that they can be useful and, for instance, support people or do a meaningful task in a given environment. So that it's not, for instance, you don't need an operator to fully teleoperate a robot. It will, if it understands the environment, the operator might set the overall goal, and then the robot has then to understand the environment, adapt, and achieve the task based on the requirement of the user. So that's a bit of the idea of AI and cognition. How do we bring this aspect in robotics to make them more efficient, effective, and useful in a given environment or to work with people? Cognitive mechatronics, then we add the mechatronic part with the sensing and the actuation, but we bring the smart element in that. So you have sensing, actuating, understanding, or in between understanding and then action. So the goal is then to improve on this loop, and so that we have better control, motion, interaction, adaptation, learning, and eventually also safer system. If you better understand your environment, adapt better to it with the sufficient sensing and the robustness and the redundancy and so on. Therefore, this is an important component to have safer system. Socially cooperative human-robot interaction doesn't mean that we want robot to have a full conversation, advanced conversation with people. It means that we want to have robots which cooperate with human in a way which is natural with people. So, for instance, even in a manufacturing environment where we have collaborative robots, the goal is to, for instance, the example which is given in the call is passing tools to a worker. If the worker has to wait for 10 seconds before he receives the object, that's not a natural way of interacting. So the idea is that the robot adapts to the user and not vice versa. So that's the idea of this socially cooperative human-robot interaction. So it has to be seen in the perspective of the user, how the robot can adapt and cooperate in a way which is useful and natural for the user. The other example we gave is this exoskeleton, which also adapt to the user. It's not a fixed one, but one which understands how to better support and help the user. And then the fourth topic, which is there, model design and configuration tools. So, yeah, when we have a user which needs to configure the system, we have to have robotic systems which are as, let's say, easy as possible to adapt and then to configure so that it achieves the task that the user needs. So you have a user which is expert in a given domain, in a given application domain, but it's not an expert in robotics. So for that, we need then to have modules and tools which are easy to use, easy to deploy in an environment, and easy to configure. So what is very important as well, if we want to have modular system, it's to make sure that there is sufficient knowledge inside the module and exchange with the other modules so that they can be plugged together. And this is why we also mentioned this standardization aspect, so that you can have a kind of plug-and-play system, right, to connect the different modules. And an important aspect when you're deploying and using those tools, I mean, we know that the problem is always in terms of security, cybersecurity, where the weaker link is. So this is why in each of the modules, each of the things you're developing, we have to take the cybersecurity, embed that from the design point of view, from the design phase onwards. So these were the 4 technologies we are focusing on. And now in terms of what we want to do is really to develop core technology modules. So we want to have a system which becomes eventually modular. So when you develop a technology, things that keep in mind that it has eventually to be integrated in a bigger system. So that's the idea here. It has to be open and non-proprietary. The goal here is, since it's focusing on developing building blocks and core technology, we expect that to be reusable by the community. So we have, for instance, Rob Moses and Rosin, which are there to help reusing modules and have a modular approach. So you have to think about this kind of approach where the goal is really to progress on core technology, then that will benefit the whole community. Now, it doesn't mean that all what you do is not proprietary in a project. You might have the development of the modules, and then you might, you might test it in a given environment within an industry. It doesn't mean that the industry has to open everything they do. I mean, in terms of testing and implementing this module in their context, they can well patent this application perspective. This is fine. So it's something to keep in mind when you design the project, to see, okay, which are the parts which are open and which are the parts which come closer to application, which then will be protected. And if you protect, then we expect you to have an exploitation plan as well. So the importance then is to have in mind to have these kind of toolkits that can be used via the platform. The platform is something which is also developed in other parts of the program, like ICT9. And yeah, the very important thing is to make sure that it actually meets the requirement of the application area. So don't do that in isolation from the application area. Bring them on board, understand what are their needs, and then develop the technology showing that you're progressing and what you're doing is actually useful for them. So that's why it's important to bring them on board, understand, and probably design scenarios where you are going to test the progress of your science and technology in those contexts based on the requirement of the user. Don't try to invent a scenario which seems to be useful, but eventually, for instance, has no market value. The people will say, okay, there is no business case behind that. So you're pushing a nice technology, a nice scenario, but it doesn't make sense in an application area. So get in touch with the application area to understand what are their needs and how your technology can meaningfully help them. And then here, this is what we ask, is to dedicate some resources to connect with the Digital Innovation Hub coming from the previous call. And the delicate part is here in the agri-food, because you will not have, you will not know the consortium on the agri-food, whether it's funded or not. Therefore, you have to, one thing you can do is already to connect to the coordination and support action, which will coordinate the activity of Digital Innovation Hub in robotics. But also you can dedicate some resources and have some plan of how you see your link to a potential digital innovation in robotics for agriculture. And then we will see if eventually they're not selected, then we will adapt at the contracting stage. We have also another digital innovation hub in agri-food, not in robotics. That could be a B plan in case the other one is not selected. So that just to give you some ideas. And so in terms of expected impact, of course, we want it's research and innovation action, so we want to improve the technical capability and demonstrate this improvement. And yeah, the goal is to show the progress, how the progress in technology impacts the 4 priority areas. And we have, in improving the technical capability, you have to demonstrate how many, I mean, that we will increase the use of robotics in those application areas to solve a number of problems which could not be solved by now. And the goal is to demonstrate at tier 3 or above your achievements. So then liaise with those application areas and define scenarios to demonstrate the progress how the progress of your technology, to measure the progress of your technology along challenges, along application defined by the users. And yeah, of course, it's then if you improve the technology, the goal is to lower the barrier within those 4 application areas. Yes, this is the names of the proposal which were selected, and all the projects have now been signed on Digital Innovation Hub. So you will see the 2 on agile manufacturing, 1 on inspection and maintenance, 1 in healthcare, and Rod in the coordination and support action, helping to coordinate all the activity of this Digital Innovation Hub. Yes, one thing I wanted to write, this one maybe. Yes, so I want to come back to the last point here, where we asked to dedicate some research to connect with the Digital Innovation Hub action coming from the previous call. And this is the time for me to give the floor to Rainer Lafrenz. He's actually running the coordination and support action, coordinating, helping the 4 Digital Innovation Hub, maybe 5, in case the Agri one gets funding. And so it's one of the contact person you can get in touch with to have a bit more information and to get in touch with the Digital Innovation Hubs and see how you can then meaningfully use those resources and how to collaborate with the Digital Innovation Hub in practice. So, Reinhard.
Okay, thank you, Cécile, for this short introduction. So I would like to just give you a very short overview from a DIH perspective, because as Cécile mentioned already, there will be a lot of DIHs around, and all the upcoming proposals, both in ICT9 and ICT10, should somehow link with them. And therefore, I would like to just give you an overview what will be out there, but I cannot give you the details, unfortunately, how to best connect. I can only bring up some ideas what could be the right way to connect, because we need to negotiate with all the innovation actions. We have some representatives. I've seen here in the room also some people involved in the coordination of those. Maybe this is the right way also to get in touch with them. Just after this session, use the time to be here, talk to all the people who are involved in the Digital Innovation Hub environment. First of all, the global perspective is here. So what we do have is, we have this kind is our robotics world. We have healthcare, we will hopefully have agri-food, maintenance, inspection, agile production. And these 4 pillars, resulting from this year's call, will be a sort of coordinated to the extent possible. We try to harmonize the FSTP funding structures, to harmonize the access via a common portal and such alike. And on top of this, we also have a kind of meta-CSA, which not only covers the robotics part, but also the upcoming digital innovation hubs from the big data, maybe photonics and other environments. And this one will bridge the link even further up to the catalog of digital innovation hubs, which is driven by the Joint Research Center in Sevilla. And this will be another thing to create a bit more transparency, because in this catalog we currently have a mixture between local enhanced competence centers, which fulfill just the criteria, up to regional hubs, which already include a couple of competence centers and such alike. And we will try to bring in a bit more clarity on what the terminology is and what kind of services could be described in this kind of catalog, and also bridging this down again to the robotics world, so that we can clearly see this hub offers clearly this list of services, and if you want to locally connect, they could also provide a link, and this is the added pan-European value, to some other hub in another area of Europe. And this, of course, is a very challenging thing, because not everyone would like to go abroad to get some service where he is or she assumes to have it in the local hub. And this will be one of the challenges. But we really need to see how to harmonize it best, and how to make very good easy access to all the things and also harmonize the terminology around funding, around services, and so on. So this is the world where we are living in. And as Cecile already mentioned, we have these 4 projects at the moment. Agri-food is still a white spot here. Hopefully it will come, but we have the project DIH Hero. Ido, you are involved in, so maybe someone else in the room is involved in the healthcare one here. We have the next one, RIMA. The coordinator is Christophe Leroux from CEA. So we have the expertise for the maintenance and inspection area also here in this room for further networking. I hope you're both still around tomorrow again. So there should be some opportunity to talk to those people, and we have also hopefully some representative from Trinity or DIH Square in the room. I don't know, Sotiris? Okay, there you are. I knew that you are here. So Sotiris is also involved here, but also in RIMA as far as I know. So there is a lot ongoing, and this link to the Meta CSA will be also broaden it up outside the robotics world. I assume that it's not only the core robotics community who is interested in the robotics technology calls, for example. Yeah, what we do from the coordination point of view, what we need to do at the moment, and this is the reason why we cannot give you a clear answer on how to interact and what exactly to write in the proposals, because we have 6 months. Our project started 1st of November already, so we were a bit faster than the innovation actions because we wanted to have some lead time. We need to use this setup phase, and we will find out how the operational models will be. And then we will communicate this with agreed FSTP timelines, strategical and operational topics. And then the rest of the project will have certain phases, how to connect with the community. But for you, when you want to attach with a proposal to the things, I can only tell you, reserve some money for interaction. Very simple things are often very helpful. So just, for example, foresee some workshops or some money to use some services of these hubs, or to do some joint activities to use the hubs to the extent possible if they offer, for example, test beds or access to different hardware, software, business planning, or whatsoever. Use their expertise. I could imagine many, many things, but we need to negotiate with the individual areas and see which kind of services also from their side would be expected to be connected to the upcoming projects. So, for example, if you are more from the research side, some interaction with the end users who might use at the end the technology could be very useful. So Moritz Butter from TNO always gives a very good example, saying that there was one case, a researcher did a very good thing. I can't remember exactly what it was. Then he came to one knowledge transfer people and said, look, you could use this technology. And the first question was, what materials do you use? Sorry, they are forbidden in this process, and all the work was wasted. So this is a situation we clearly want to avoid. What we really want to do is to have a joint activity where the benefit of all the stories can be clearly seen, and also the benefit for you as a proposer to increase your work or to bring your work into practice, and also for the hubs to get new contacts to experts and to new, fresh ideas from the research side. So it can be a mutual benefit if you play it the right way, and this is what we should do. Thanks.
Thanks a lot. We have to move fast because we might be kicked out of the room at sharp 1:15. I forgot to mention that if you are going to work on a proposal, prepare a proposal, there is a service offered by the Idealist, and they're organizing a workshop tomorrow morning. They left some paper there to inform you. So use these services. This is for free, and you can get a very nice information and clues and help from them. So use that. This is for you. Then I will call now who are the presenters for the IDs? 1, 2, 3. Okay. So the number 1, can you display the first? They were in the order as they are in the website. I will give you, let's say, 2.5 minutes would be perfect. It's not too much. Yes. take one now while we are moving to, can you display the first? Okay, yeah, we take it in the, yeah, tell me.
I realized that you're talking about application area sort of in singular.
Yeah, okay.
So that's a question, would it need to address one or more?
Okay, so the question is, I'm talking about one application area once at a time, but it's up to you. You have a grid of the 4 technology, a grid of the application. So you have matrix there, and it's up to you to select whether you want to focus on a single point in the matrix or address a number of those. So you can have a line, you can have a column, you can have more. So that's up to you to select one, yeah.
In terms of technology, the code says one.
Yeah, it says one, yeah, but it could be one or more, yeah, yeah. And by definition, I think it would be probably one, a focus on one, and then some coverage of the other. Yeah.
Okay, if I've got 2 minutes, I'll just skip the slide. So you know where I am and who I am. So just we want to increase the autonomy in this call. So what I see, which is missing or not fully exploited, is the physical interaction with the world and physical perception of the world. What I mean is the physical properties of the materials that we are interacting with in terms of walking, driving, anything like that. So ground vehicles, and also like manipulation. So I would like to have agnostic to the type of robots, AI and cognition, and also supported by cognitive mechatronics because we need sensors and control to sense this and have this physical interaction done properly as a module which could be used. In healthcare, we've got soft tissues. In agriculture, we also have food, anything like that, which is also like soft. We have maintenance and inspection, so we go with any type of ground we can imagine. It's always tough. And we also have, what I missed? Agile production, so we have different types of materials, whole variety, and it's always physical interaction and physical materials that we have in our grippers, hands, anything like that. Thank you very much.
So good afternoon. My name is Robert Wojcik. I'm coming from an Austrian SME and would like to introduce you on model-based design and configuration. We are a meta modeling company. We are implementing meta modeling platform since 25 years. It was a core secret since 5 years, and now we give it for free for research. How do I get the next slide? The green one, thank you. We have some labs. One lab is in University of Vienna. If you have time to want to visit it, you can go there. One lab is looks similar like this. It's in our office. It's at Karlsplatz. If you would like to visit, feel welcome. The idea is you have business application layers on top. You have the technology layer on the bottom, and you have conceptual modeling layer in the middle. And from the one side, you have requirements. From the other side, you have abstractions. And this is what we are elaborating. Are we alone? Are we new? 2,300 developers worldwide. We have about 3,000 stakeholders. We have 14 universities, 9 laboratories, etc., etc. So we are not quite new, but in terms of robotics, we are just starting since a couple of months. So if you would like to join us, we are very happy. If you don't like us as a partner, you can download the software for free. You can download all the requirements for free. Since next years, we give everything for free, how to build up this lab in a project which is called DigiFof, which especially trains design for this type of physical systems. If you want us as a partner, we can go along implementing new stuff and bringing on more. That's my contact. Feel free. I would be happy to participate something with you.
So I'll start with all the slides. No, it's not mine, sorry.
Okay, so to address the challenge of model-based for robotics, we propose to build an autonomic, trustworthy artificial intelligence product line. Okay, so green, yes, the big one. Okay, so in critical domains like healthcare and maintenance, we need to certify the safety, dependability, cybersecurity of the system. It's challenging right now for AI because we combine declarative knowledge and the flow of control has not been designed by a specialist of the domain. They just state rules or Bayesian networks, and then an inference engine is combining this sometimes non-deterministically at runtime. And the inference engine has been done by specialists of the mathematical formalism underlying the engine, but not of, for example, healthcare and not of maintenance. So it's a challenge, and moreover, those declarative knowledge structures are more and more learned from data and through a very complex process of data selection and machine learning with tons of parameters to set. And how can we guarantee that the result is safe and secure? Also, AI is a big labyrinth for most systems and software engineers. AI is very siloed, and right now what's missing is kind of self-configuration to help you from the requirements of a robotic application for each part, each subsystem, which kind of AI you use, which reasoning paradigms, which knowledge representation, which machine learning techniques. Nobody really knows because every AI specialist is specialist only in one techniques. So we want to use this idea of product line engineering, where we will model the problem space of robotics apps, the solution space of AI components, and then use one of those AI components to do an AI task, which is configuration, automatically to help you design your system, your robot. Also, we are for AI, there's a lack of interoperability between the various components, so we want to address that. It's the part of standardization for the call, and to address this block. So we want to develop a product line of this. For the underlying formalism, we want to use machine learnable probabilistic logic rules so that they can be understandable and explainable, by example, for safety auditors. We want to compile them into, for example, JavaScript for software and FPGA for hardware, based on previous research has been published. We want to make clear interface between that kind of rules and sub-symbolic AI, like the deep neural net, that are the only solution for sensing and low-level control. And then the idea is to, once you have a product line, you have a variety of AI service to use in your robotics application, but it can also be used in the model-driven tool to help you, for example, configure automatically this thing, and also to provide some autonomic, to help you reconfigure at runtime depending on the context for self-optimization, self-protection, and self-healing from, for example, cyber attacks. And also be self-verification. So you can use some deductive, for example, components to prove some critical properties of your robot or of some AI components that you've just assembled inside your robot for a specific subsystem. And also, finally, you need to write the documentation that convince an auditor that to certify your robot as safe. And here also AI has something to contribute because there is a whole literature on legal reasoning and argumentation where you can use AI to look at some of the proof that you've done with the self-verification modules, analyze the trace of your process. It's in some model-based, so you have a process model that you keep a trace of every part of the development that you've done, and use this meta AI to organize evidence that you've followed properly the standard, the safety, dependability, cybersecurity norms to present to the auditors. So here, we already have a consortium with the AI partners, and we're looking for a robotics partner, because right now in our consortium we have no robotics partner. So we could merge inside a larger project or aggregate inside our projects robotics partners, robotics researchers, and also providers of pilots, SME, large companies, that kind of thing. Thank you.
So hello again. So I'm representing a research center named AirCam in Paris. So we are working mainly in sound and multimodal interaction, and seeing the call, we imagine that now our technology bricks could be applied also to robotics. Okay, so we are a lab of about 150 persons, supported by CNRS and Sorbonne University. We are also very active in licensing, also in European projects. We have currently 10 ongoing, and also in industry transfer and startups. So yes, so 3 main ideas. First, so we have developed a gesture recognition system so that the robot could identify the gestures of the human user. But also, this is a system that maps the time of the gesture so that the robot could react during the gesture. And so this is a first feature, I think, that could be adapted to robotics. And there have been several projects and several prizes on that, and also, by the way, on the prize for startups here. The second aspect is what we call computational audio scene analysis. That is, we can analyze an audio scene, so the robot can analyze, can separate the various sources that are simultaneously here, both simultaneously and also over time. Also localization of the sources in space, and then identification and identification of speakers. And all this can be combined in global models. And the last thing I wanted to propose is in the case of speaking robots, also we are working on processes of changing the speech and also changing the emotional content according to the context of interaction. So this is the basic bricks that I would like to propose in a project. Thank you.
Thank you to everybody. If there is one quick question, yes.
Just a small question, and for show of hands, how many of you are taking part in the event on the 18th of December in Brussels?
Yeah, I want to mention, we have a brokerage event on the 18th of December in Brussels. I have to say that for the moment, we have 170 registered, so there are people on the waiting list because the capacity so far is 150, so I'm trying to find a solution. So how many of these, the people here, are registered to that event? Okay, not so many. Interesting. So what we're going to do is do the similar session, but more extended one, and give the floor also to project IDs. There will be a poster session as well, and we will ask to the proposers and to the people attending if they agree to put their presentation and share it with everybody. So the goal is to share as much as possible the information we will gather there, and yeah, that's the idea. Thank you.